I want to do a couple examples here about solving series circuits. So we have a voltage source over here of 11 volts. We have a 2 ohm resistor 1, 4 ohm resistor 2, and 3 ohm resistor 3. And we're supposed to figure out current, each of the voltage drops across the resistors, and what the total resistance is, or the equivalent resistance. You don't have to do these in any particular order. For instance, I think that finding equivalent resistance would be the fastest and the easiest, because you just have to add up these three resistors. They're in series, and so the total resistance is just the three put together. And so that's 6 plus 3, which is 9 ohms. So that was just the easiest and quickest one for me, but you don't have to do that one first. That wasn't necessary. Okay, but now that we have done that, I can figure out what the total current is, because I can use VT equals IT times RT. I can use Ohm's law for the total. Okay, and so that's what I'm going to do. I'm going to do it up here. Here. VT equals IT times RT, or REQ. I am going to use T just to keep the subscripts consistent, but it's the same thing. Okay, and so now we've got 11 volts equals the total current times the equivalent resistance, which is 9 ohms. And so when you do 11 divided by 9, you get an I of 1.2 repeating amps. We're just going to go 1.22. So that is the total current. Now we remember that any current traveling through one of these resistors is the current traveling through the total. Now we know the total first, and that means that's the total current coming out of the voltage source. That means all of that current has to travel through R3, R2, R1. Again, the order does not matter. So if I know that 1.22 amps is going through R1, R2, and R3, I can use V equals IR for each of those individual resistors. So I'm going to do V1 equals I1 times R1. V1 equals 1.22 amps times the resistance of resistor 1, which is 2 ohms. And so there I get a voltage drop of 2.44 volts. I'll do the same thing for V2. V2 is I2 times R2. V2 is 1.22 amps, because it's the same current traveling through every component. And then we've got an R2 of 4 ohms. So V2 is equal to 4.88 volts. So the voltage drop across R2 is 4.88 volts. Now we've got some choice. Either we can do the same thing again for R3, or for V to calculate V3 in this case, or we know that the total voltage drop has to add up to 11. So the voltage increase at the source has to equal the total voltage decrease around the circuit. And so if that's 11 and this is 2.44 and 4.88, then we can just subtract that from 11. Now that won't give us an exact answer, probably, because we rounded both of those other voltage drops. Okay, but I'm not going to be fussy about that. That is totally fine if you use your rounded numbers to calculate your final number. Okay, so that's what I'm going to do. I'm going to go V3 is equal to VT minus V1 minus V2. So V3 is equal to 11 volts minus 2.44 minus 4.88. And that gives me a voltage drop of 3.68. 3.68 volts. Feel free to check that the other method as well to make sure that you get the same answer. But we should also see that the biggest resistor drops the most voltage. It uses up more electric potential energy than the smaller resistors. And so we should see that R2, the voltage dropped across there, is the biggest, 4.88. The other two are smaller. And we should see that the smallest resistor, R1, has the smallest voltage drop, and it does. Now, V3, we calculated it using the other ones, so if we made an error, it would have been passed along to R3 as well. So you do have to be a little bit careful and maybe double check your work. For the second one, we're given total voltage, 24 volts, we're given R1 and R3, and we're given the current through the second resistor, but we're not given the resistance of the second resistor. So we're supposed to find equivalent resistance, V1, 2, and 3, and we're supposed to find R2. So we can't jump straight to equivalent resistance because we don't have R2, right? Because then we could add them up, but we don't have R2. But we actually could jump straight to equivalent resistance if we wanted to, when we recognize that I2 is also the same as I total, right? This current, this 2 amps, if it's traveling through this resistor, also has to be traveling through the rest of the circuit because there's no other path for it to follow. And so I am going to find Req first. So Vt is equal to It times RT, or Req, same thing. So I know that Vt is 24 volts. I know that It is 2 amps. And so then I can solve for RT. Divide by 2, and I get the equivalent resistance is 12 ohms. Okay, so all 3 of these resistors together need to add up to 12 ohms. And that allows me to also figure out what R2 is, right? If I know that all 3 of them together add up to 12, and R3 and R1 add up to 10, that means what's left for R2 is 2 ohms. Now maybe when looking at this question you saw a different order to do things in. There definitely is a different order to do things in. Pretty much any circuit that you're solving, you'll find that there's different orders to do things in all over the place. And so you can choose however makes sense to do it to you. I usually see puzzle pieces. So I see one piece that will allow me to connect to another piece, and that will allow me to connect to another piece. Okay, and maybe you see them in a different order. Totally fine. So I now should be able to calculate V1, 2, and 3 for all 3 of these pieces. Okay, I should be able to do that because I know the current traveling through all of them. So R1 is 4 ohms, I1 is 2 amps. So then I can use V1 equals I1 times R1. So V1 is equal to 2 amps times 4 ohms, which gives me a total of 8 volts. So 8 volts is dropping across V1. Now we can do the exact same thing for the other two. So I2 is 2 amps, R2, we figured that out, was 2 ohms. And so the voltage drop across R2 is going to be 2 times 2, which is 4 volts. And then if we do the same thing over here for R3, we get a current of 2 and a resistance of 6. 2 times 6 is 12 volts is dropping across that one. We could have also looked at the total voltage, it's 24 volts. And if we know R1 has a voltage drop of 8 and R2 has a voltage drop of 4, that's 12 altogether. And so you can subtract that from the 24 to get the last one. So you see there's going to be multiple options for figuring out all these pieces.